All right, let's look at this problem. Calculate the buoyant force on a 2-liter helium balloon. Given that the mass of the rubber in the balloon is 1.5 grams, what is the net vertical force on the balloon if it is let go? Neglect the volume of the rubber. Okay. Now for this problem, I went ahead and looked up the density of helium. The density of helium is 0.178 kg per meter cube. 1 kg is 1,000 gram and 1 meter cube is 1,000 liters. So this factor cancels. So essentially, the density of helium is 0.178 grams per liter, and that of air is 1.225 grams per liter. Okay. So for part A, what we want is, so here's a helium balloon. We want the buoyant force. Now, Mr. Archimedes says the buoyant force is equal to the weight of displaced fluid. And the displaced fluid was air, so this force is equal to the weight of this much air. Okay, and so this is equal to the density of air times gravity times the volume of the helium balloon, which is 2 liters. Okay, so this is equal to 1.225. Oh, I guess we'll have to keep this in SI units. Meter cube, G is 9.8 meters per second square, and the volume is of the helium balloon is 2 liters, and 1 liter is 10 minus 3 meter cubed. Okay. All right, so this works out too. So let's add a page. Okay. So the buoyant force works out too. Okay, 24 millinewton. So that's the upward force. And so now part B asks you what is the net force. So this is the buoyant force, and here is the weight of the balloon. Okay, and this is equal to mass of the helium plus mass of the rubber times G. Okay, so the net force is the buoyant force minus mass of helium plus mass of rubber times G. All right, what we'll do is we'll calculate the mass of helium and that separately. All right, mass of helium is the density of helium is 0.178 grams per liter, and we had 2 liters of helium. So this is equal to 0.356 grams. And the mass of rubber, of course, was given. It's 1.5 grams. All right, let's add another page. All right, so the net force is the buoyant force minus m mass of the helium plus mass of the rubber times g, and this is the buoyant force is 24 times 10 to the power of 3 minus 3 newtons. Mass of the helium is 0.356 grams plus the rubber is 1.5 grams. So you see the helium is the balloon itself weighs about 5 times the helium. Okay, and then we have to convert that to kgs. 1 gram is that many kgs times 9.8 meters per second squared. Okay, we'll keep this 10 to the minus 3 common. Okay, so it's 24 minus, and this plus that is 1.856 into 9.8 into 10 to the minus 3 newtons. All right, so it's equal to 5.8 into 10 minus 3 newtons. Okay, so the net upward force, and essentially this is equal to, well, mg with g. If you divide this, if you divide, oops, if you divide this by g, so that becomes 10 minus 4.58 grams. So essentially the weight of half a gram is the net force on the helium, upward force. All right, that finishes this problem. Okay, so we can stop the recording.